And thank you for joining our session today on our test development challenges holding you back. My name is John Szymanczyk. I'm the Director of Marketing at Marvin Test Solutions, and I'm pleased to be here this morning with you. I hope everyone is healthy and safe, and we'll get started. So today we'll do a brief introduction on Marvin Test Solutions. We'll talk about some of the test development challenges facing test engineers, both from a hardware and software perspective. Then we're going to take a look at what we refer to as the test engineer's development suite, take a look at how the integrated test executive plays into the overall solution set, a few comments on cybersecurity and how this plays into today's environment, both from the standpoint of development, execution, and deployment of our test programs, and then some recommendations. So the Marvin Test Solutions is part of the Marvin Group. The Marvin Group is the largest US-based supplier of aircraft armament equipment, pylons, bomb racks, ejector racks, and so forth. Then we have the Land Systems Group, which focuses primarily on auxiliary power units, environmental systems, and so forth. And then Marvin Test Solutions. We're a test solution provider, whether it's ATE systems, full-blown systems, software solutions, pieces parts, could be PXI, instrumentation, switching, as well as the overall solutions. And then the integrated development environment is all part of that as well. So we're a vertically integrated test solutions leader. And what we mean by that can essentially be seen from the images on the right-hand side of the screen. We design and develop PXI and PXIe cards, as well as power systems, subsystems, chassis and the like, and then very large complicated systems such as the one on the right hand side, the TS320, which can go as high as 4,500 test points. And then of course we can't forget the rugged portion of it as well, and then the software, which we'll be talking about today. We're customer-centric aerospace manufacturing test company, and that's a key part of this because we're AS9100D certified, which puts a lot of requirements in place that an average instrumentation company or switching supplier may not have. And then we're globally deployed. We have solutions around the globe, and we continue to support our partners, both military and aerospace, as well as the commercial side of it. So let's look at some of the test development challenges that face test engineers. We know when we take a look at the entire, if you want to call it the ecosystem that the test engineer has to deal with, there's lots of pieces to it. So whether it's analog resources, DMMs, arbitrary waveform generators, those types of things, digital resources, depending on the type of testing that's being performed, as well as, and you can see most of the images you see are PXI, both 3U and 6U based, but also the center image here, obviously, we also have to integrate pieces with different types of interfaces. So I might have my PXI cards in a chassis as well as my switching subsystem, but what if I need a high performance oscilloscope, for example, or some other type of instrumentation that requires different type of interface integration. It could be LXI interface, could just be regular Ethernet, USB. So really the test engineer is faced with a lot of different aspects and a lot of different pieces that have to be stitched together. And then we bring all that together through the interface resources, the interface test adapter, and then all the cabling and interconnects that are part of this. And then the very top of this image is what we're going to focus primarily on today, and that's the software resource piece of this. I developed test systems for Northrop Grumman and Westinghouse, and it always seemed like the hardware piece of it, we could get our head around pretty easily and pull everything together. But then if you didn't have a comprehensive tool to do your test development, the sequencing through a test executive, and then in today's environment, being aware and addressing issues that are focused on cybersecurity, this is all piece of that software resources and how do we come up with a solution that will provide the kind of performance as well as security we need. So when we think about that from the standpoint of test software requirements, what are the kinds of things that you need when you're evaluating your test system in future requirements to ensure that we can provide quality results, but without having to reinvent the wheel each time we go about providing a solution? So questions like, do I really need an integrated development environment and executive sequencer all built together? What about cybersecurity safeguards? Are you doing work for the government and military and even commercial bases these days? So if so, then we need to be concerned with these things. How about the availability of development hardware? Do you have a team of test engineers that is going to be performing these activities, but we only have 1 or 2 stations? So how do we address those type of activities? Do we bring people in on 2nd and 3rd shift? Do we buy additional hardware for development? Those types of things. Depending on your customer, documentation is going to be a key piece of this. So do you reinvent the wheel and develop your own type of documentation resources, or do you look at a tool that has it all built together? What about the programming language? We find typically that test engineers are folks like myself. We're double E's. However, we do a lot of software work, or have done a lot of software work. So what type of programming interface and environment is going to be the most effective for our test engineers? Long-term system support's a key thing of it. What if I deploy a system today, but like many of the military aerospace programs we see, it's going to be supported for 10, 15, take a look at the B-52 bomber and the hardware that goes in there. So we really need to be concerned about support depending on our customers. And what about the process flow, the definition in building out the test programs? It really helps if you have a type of environment that provides a flow that's similar to the technical requirements document. So all that being said, then, if we break it apart and we look at how the pieces fit in to the various areas of the environment, you have the development environment, the executive, and the cybersecurity piece of it, which I break out here. And if I'm looking for well-defined processes that we talked about in the previous slide, well, it's got to be framework driven. We want a test engineer's environment that flows and follows our requirements document pretty closely, so I can go back and forth and ensure that I'm addressing all the key issues and key test parameters that are required, but both internally and for the customer potentially as well. And so forth. What if I don't have hardware available? We talked about if I have only a couple stations, but I have a team of test engineers that need to be doing development. What about simulation? Might be a nice tool. And then when we look at the executive, having an integrated executive rather than 2 dissimilar pieces or 2 pieces that I connect together through various hooks, and this ties into cybersecurity. We need to make sure that the entire environment is safe. From a test engineering standpoint, I need to be able to troubleshoot and debug effectively. I need to have the tools in place so that I'm not out there creating my own tools or importing third-party tools when I'm doing my debugging and so forth. And then let's not forget about the test results. Depending on your customer, they might have well-defined ways that they want the data presented, and report generation and flexible report generation is really a key part of this as well. So these are all things we need to be concerned with when we're looking at our test development. So now we're going to look into what we refer to as a test engineer's development suite, and that is ATEasy. If you're not familiar with ATEasy, it started, I'll show you a timeline in a minute or so, but it was designed by a company of test engineers for our customers who are test engineers. So really that was our focus when this started, was how do we address the issues and concerns and challenges that we as test engineers have run into in the past and test engineers today continue to see. it needs to be easy to program. It needs to be easy to review and debug and so forth. We've had a lot of feedback saying that, hey, we really like the interfaces associated with the programming interface like VB, but we also need this flexibility and power that you get from a Visual C++. So really being able to combine those in one integrated package really is helpful. From the standpoint of framework driven, it's important that we don't have, if I have a team of test engineers, that everybody's not off doing things a little bit differently. We really want to be able to have a streamlined framework-driven approach that if one engineer is working on a particular project today and it's released 3 months later, we have some issues we need to look at or fix, and that test engineer is off doing something else, so we can put someone else in their place, and without having to reinvent the wheel, take a look, understand what the framework is, and be able to move forward. And really, the integrated development environment can't be understated. It's having this test sequencer, the test executive, depending on your the terminology you like to use, but having this integrated together. And this really simplifies the overall development, deployment, as well as setup and troubleshooting. So ATEasy hasn't been around for just a couple years. It was originally introduced in 1991. You can see we continue to implement, install fixes, as well as enhancements. In the fall of this year, we'll have the version 11 being released. So it's a pretty impressive timeline from this standpoint, but also the longevity piece of it is critical for our customers as well, because as I stated earlier, you look at some of the military programs, and I love using the B-52 because who would have ever guessed the B-52 would be flying today, but we're still supporting that mainframe, but also we're enhancing it. So being able to have a software tool that provides that longevity is really key as well. So what about the, we say it's a test engineer's development seat. Well, let's take a look at the user interface for a moment. It's really well-defined and well laid out, and it should look familiar to us. I mentioned a VB type of interface with the power of C++. Take a look at the image here. It really does provide that type of interface. So you have text-based programming, standard toolbars, all of our log windows, interfaces, status bars, and everything we would expect to see in our development environment. So when we think about what's important, what's going to provide the most impact and make us most effective, easy, intuitive programming really helps. There's no question. Having the flexible interface, whether it's using the menu-driven approach, or whether we've been programming a particular instrument so long that we have the command structure memorized and we know what we're doing from the standpoint of being able to type that in. But on the right-hand side, you can see it's a good example of being able to show suggested completion for unfinished statements. Whether it's providing, in the case of the switch subsystem, it gives an explanation of what it is, and it provides some prompting, or from the standpoint of the DMM down below, and you can see you actually have the various parameters shown that we can select and click and select. Being able to have readable programming, easy to go through from the standpoint of an understandable, and we use the term English, but an understandable English language statements where I can just step through. And on the right-hand side in the red box, you can see it's stuff we all saw in college. It's real familiar, if then else type statements, really straightforward. We need to be able to, from the standpoint, again, of maintainability and long-term support, a key piece of it is the instrument interchange technology, or I2T feature. What if 3 years from now, that great DMM that I implemented and put in my test system is obsolete, it's no longer available? What do? Well, I don't necessarily want to put in a new piece of instrument, requalify it, have to go back out and requalify all my TPSs that are already deployed. Not only is it time consuming, but it's very expensive. So you want to avoid that. So having this I2T technology allows us to swap out hardware with standard functionality with a replacement piece, minimizing the type of impact it's going to have on my code. I mentioned TRD requirements flow. So let's take a look. On the left-hand side is a requirements document, and it starts off for the UUT power supply testing. And oftentimes, this is the way it's laid out. Okay, this is my 3.3 volt test. My pass criteria for the shorts test is going to be less than or equal to 33 ohms, and so forth. As you step down, you see the various testing. Well, when we put this into ATEasy, you can see you have essentially that same flow. We have our power supply test, 3.3 volt and 5 volt for the shorts, and then the power for the different rails as well. And you can see that this is all broken down into a well-defined structure, and it's broken out from the standpoint of test property in the code itself. And we'll see another example of this in a couple slides, but it's really an effective and efficient way to take the requirements from our requirements document and put them into my test development environment, ATEasy in this case. So we break it down very logically by task, test, and properties. And this example here, you can see in the first on the left-hand side up top on the task, it's power supply tests. Then that's broken down into my tests, which are 3.3 volts and 5.5 volts. And then those properties for the tests oftentimes can be pulled down into drop down. So you can see from the standpoint of the bottom one, that's my 3.3 volt supply property test. And you can see where the drop down, for example, the type, it's a min max, or it could be greater than, less than, equal to, you name it. So you're not actually having to go in and type these things in. A lot of the programming is drop downs that make it really intuitive and easy, as well as documenting what's going on with these particular tests. We have what's referred to as rapid application development tools. The next slide will see exactly what I mean from that, or by that. But it really helps from the standpoint of implementation and debugging segments versus having to compile and run the entire test, find out I have errors, then start slogging through all those various pieces rather than doing the testing and the debug on little sub-segments. A key thing when I'm deploying my various applications throughout the company, the United States or world in many cases, it's important to have a royalty-free runtime executables available that we can deploy without having to worry about my royalties every single time I go out and deploy this to a new site. And then backwards compatibility is always key, both from software and hardware. So this is an example of the type of functionality you would expect to see from the standpoint of the rapid application development. And it really does impact workspace efficiency. So for example, if I'm having an issue with a particular test, I can run through a test using this tested button that will just, on the previous slides, we saw the test broken out, and it will just loop and it'll run this piece. So I can validate the performance of a subsystem. The same goes for do it. And that would actually expand and do additional testing. And then from the standpoint of forms, I can run testing on the whole form or just the task itself. So depending on what the issue is, what I'm trying to validate or verify, I don't have to, again, compile and run the entire test. I can do, or the entire TPS. I can actually build out and test various subsystems. From the standpoint of debugging, that's another key thing. Years ago, and still today, there's third-party tools such as SPY. So, all right, the test isn't working the way I expect it to. I'm not closing the right relay contacts I wanted to. What's going on? Am I setting the right commands? Is there an issue with the wiring? Is there a concern with the driver, maybe some other issue? So what I can do using built-in tools, monitor window in this case that you can see on the right-hand side, and that allows me to actually monitor what's being passed back and forth from a command standpoint to my meter, to my switching, whatever the case may be, and I can take a look real quick and say, oh, okay, now I see why I'm not getting the right AC voltage because I programmed it for DC. A silly example, of course, and wouldn't expect to see that, but it really does give us a really quick visual representation of what's going on, and helps and greatly reduces time from a debug standpoint. And this is delves into that a little bit more, but you can see that built in, you have the ability to pull in additional debugging features, stuff such as stop on fail, single step, being able to go through and validating, that we're getting the impact, in the performance that we expect to see. You can set breakpoints. Okay, when I run to a certain spot, I want to stop, and then when we're ready to move on, then we can continue to execute the test. So really, having built-in, very functional debug tools saves time and provides us with a better product at the end. Collaboration tools is another key piece of this. So it's not uncommon to have multiple test engineers working on TPS development at the same time. And all the various pieces at some point need to be integrated together. And it should be done easily, quickly, and efficiently. And having built-in collaboration tools to compare and merge really would, or not would, but does provide significant performance improvements. And you can see down below is a quick example. And depending on the type of change, it would be highlighted differently. So you can actually go in and validate and merge and so forth. And fault identification repair is another key thing for any test engineer. We're testing it, but obviously everything that comes off the line is not going to pass, and it's not going to be 100% ready to go. So what we need to be able to do is easily integrate next step actions for our technicians when they're actually running and performing the tests. And having the ability to program this quickly and easily really is another time saver. So again, typical type information. We go through the various results we're getting from our tests, indicate that U1 is defective, and then we provide the test engineer with the correct action. And then being able to test multiple UUTs is always a nice feature as well. And where I've run into this before is when I've done halt-has testing or life testing, where I'm putting multiple devices inside an oven or on a shaker table, something like this, but I don't want to run these sequentially. So within ATEasy, you have the ability to go in and run these tests in parallel, greatly saving time and improving efficiencies. Any effective test development environment has to be open architecture. We have lots of pieces from different places, code snippets from different areas. We may have a really cool control that we want to put on our user interfaces, these types of things, as well as being able to support all the various hardware interfaces out there. There was a day when it was GPIB, right? And then, GPIB and serial. Then we threw VXI in there. And now we have, a broader array of interfaces that must be supported and used. So this is just a quick example of how easy it is to implement. Let's say we wanted the calendar object to be implemented. We can simply go to libraries, we insert an object, we pick the control we want from our ActiveX controls or .NET assemblies, DLLs, whatever the case may be. We select that, and the next thing you know, it shows up on our controls palette. So really straightforward. And then the same can be said for LabVIEW. So let's say, for example, I have some code that I wrote in LabVIEW, and it's like, man, I don't want to switch. Yeah, this is great. It looks like a great programming environment. I love the fact you got the test exec all integrated, but I've invested a lot of time in this other environment, whatever that may be. And this is just an example of how you can import VIs directly into ATEasy as well. And then simulation is a key piece of. We talked about having to do development, co-development when I may not have my full test system hardware available for the entire team. Being able to do simulation and have simulation definitely saves a lot of time, and it provides us with significant improvements from the standpoint of resource utilization, both human and machine. This is a quick example where you can see, all right, I don't have my DMM available, but I know if I'm running my test and I get this particular result, then it's either a pass or a fail. So I want to go through and continue to do my testing. And you can see the result is on this screen, where down below I have my DMM simulation. I have that 6-volt result that I programmed in the previous slide, and lo and behold, I get a pass when I run my test. So again, it definitely helps from the development and implementation standpoint. Now let's take a look at the test executive or sequencer. Being able to integrate your sequencer or test executive seamlessly into the integrated development environment really is key, because we can't just program. We need to be able to select and create and debug tests and run and view and print log files, provide our customer with detailed results showing that, oh, the test did pass and so forth. So the test executive is all piece of this, or is all part and parcel to this. So we need to, it generates, ATEasy generates automatic log files. You can modify these, control them from the standpoint of look and feel and layout. Being able to integrate the various languages, we talked about that. Multiple UUT testing. So most of these things we've actually reviewed in the past, but a key thing as well is the type of interfaces that we provide our users. If I'm a test engineer and I'm out there on the floor and I'm doing some debugging or I'm running my tests, this is the type of interface I want. I want to be able to see what's going on. I want to be able to take a look at the various tests, the tasks, and so forth, and ensure that indeed the things that I expect to be happening are. And if I'm getting a fail, I want to be able to take a look real quick and see what's going on. However, if I'm deploying this on the floor around the country, around the globe, I probably don't want my test technicians on the floor seeing the same type of interface and having access to the same information. So then we can go to a modal type interface. And this is just a real quick example of what that would look like. But again, this can be modified, tweaked, and customized using different types of tools as well, in different, whether it's a .NET control, something like that. So really you have a lot of flexibility from that standpoint, but ultimately your user sees a keyboard. They have really well-defined buttons that, okay, start the test. The next thing that comes up might be enter the serial number and this type of thing. So it's designed to provide different type of interfaces built in based upon who is running the test and the type of performance and work they have to do. Now let's just take we're coming on the top of the hour, and I want to be respectful for your time, but we'll just take a brief look at cybersecurity and some recommendations for you. Cybersecurity is a key topic, and it impacts all of us, especially if we're delivering any type of systems to the military and aerospace these days. And I guarantee our commercial customers aren't any less concerned about cybersecurity than our aerospace customers are. So what ATEasy does, it incorporates solutions to issues identified in the STIGs, which are Security Technical Implementation Guides put out by the DoD. And they are definitely the trusted resource for guidance in issues, policy, security tools, and so forth. But from a test standpoint, there are two things we need to be concerned about: operating systems and the application security development STIGs, which are ATE-based STIGs. And of the 300 some odd risks that are identified for application security development, there's about 60% of them that are really critical and essential for us to focus on as test developers and TPS developers. And obviously, you take a look, idle time locking, right? You have a tech walk away from the test station or development engineer, and they're gone for their break. We want to make sure that that station doesn't stay open for 4 hours while they're gone. I know, nice long break, right? But just an example, user account handling, being able to log what's going on from the standpoint of both access as well as what's happened within the system. If I have a file that's been modified, I want to know who did it, when they did it, and why they did it potentially. So being able to provide these type of controls is really critical. And ATEasy is compliant with the current version, which is version 4, release 7, and it provides all these controls and functionalities. Being able to do audit logging, knowing when sessions started and stopped, inactivity, password policies, both from the standpoint of individual users as well as groups. So really, there are a lot of aspects of ATEasy from the standpoint of being compliant with cybersecurity requirements that really shine, and it really stands ATEasy apart from all other solutions out there, especially when you start looking at that integrated set of your development environment and your test executive. And that goes to the point of configuration management, being able to ensure that I have the various controls in place, being able to encrypt my files. We need to ensure that even when I deploy, I need to ensure that I'm encrypting the entire set so that I'm not exposing it to various types of attacks that it may be exposed to. Now let's take a real quick look at recommendations. So ultimately, we've taken a look at all the various issues that I need to be concerned with. From the standpoint of having a familiar programming interface. We have that VB interface with the power of C++, essentially. Being open architecture from the standpoint of longevity, having the cybersecurity features in place. That's really key, and we can't overlook that. And think we'll get to it later because there's a lot involved to ensuring that your systems are safe. And then tools such as the Rapid Application Development Framework that will provide your engineers with a really robust development environment that is common and that is very simple to step in potentially weeks or months later as another engineer coming in on the project, and being able to come up to speed quickly using these very standard interfaces and tools. Now, from the standpoint of taking a look at this, we invite you to take a look at ATEasy today. You can go to the website, download it, 30-day free trial, and it's not a version that only performs some of the functionality. It's a full-blown development environment. So you can download this, start playing. You can actually write code with it in examples with the various hardware you have today. Being able to train your team up, for example, if you decide this is an approach to go. We have these development boards, and we have college level syllabuses in self-learning books that you can bring your team up to speed really, really quickly on. And then if you have additional questions, you can contact Jim Frame. Jim Frame is our Director of US Sales, but also you can access a lot of support online using Magic, which is our online support structure for both customers and those doing evaluations as well. Now we're at the top of the hour, and I apologize. I want to be respectful for your time, and we're about 3 minutes over. So what I would like to do, if you have questions or comments regarding this, please, I'll keep the window open for a little bit, post them, and for those, and then we will we'll terminate today's activity because I know we need to get you guys going, but then we will respond via email and address any questions or concerns that you might have. So on that note, I would like to say thank you for attending. Again, please, we wish the best to you personally as well as your companies. We hope you're staying safe and secure in these challenging times, and we look forward to hearing from you and working with you to address your various test challenges that you face as you're moving forward. So thank you very much. Have a great rest of your day. We appreciate your time.